Carrying on from the previous video where we looked at the two translating transformations, we're now going to be looking at the stretching transformations and the reflecting ones. So starting off the stretching, the general form for a stretching transformation would be like y is afx or y is fax. We'll look at each one separately once again. So let's look at this one here where the a is outside the function. In this case, it's going to stretch the y values by a scale factor of a. So if it was like y is 2 f of x, then the whole y values will be multiplied by 2. So if I were to sketch the graph, f of x is x minus 1, x minus 4. We know it crosses the x-axis at 0, 1, 4, and the y-axis at y is 0. So it's going to be a cubic function like this. Now, if I was to sketch the graph, let's say 2 f of x, then the whole function or the whole graph would stretch by a scale factor of 2, like we said before. So if I was to sketch that, it would look something like so. Now, the second stretching one is when the a is inside the bracket. So let's say y is f of a of x. In this case, it's going to affect the x-axis. And like the one in the previous video where the a was inside the bracket, you have to think to yourself, it's going to do the opposite of what you'd expect. So if it's a times x inside the brackets, rather than multiplying the x-axis by a, it's actually going to shrink it by a. So that means we just divide the x values or multiply it by 1 over a. So going back to the original function, if I was to sketch y is equal to f of 2x, that means it's actually going to halve the x values rather than stretching it by 2. So originally the x values were at 0, 1, and 4. If I do y is f of 2x, they're now going to be at 0, half, and 2. The y values will not change. If I was to sketch y as f of a quarter x, in this case, it's going to stretch it by 4, but you can think of it as 1 over a quarter, which is 4. So now the x values are going to be at 0, 4, and 16. So you can see that depending upon what the a value is, you have to be very careful which values it will stretch. If it's outside the function, it's going to stretch the a values or the y values by a. If it's inside the functions, it's going to shrink the x values by a. And lastly, the last two transformations are actually reflections. So they're going to be either y is minus f of x or y is f of minus x. Now, if the minus is outside the function, like minus f of x, then it's going to affect the y values. And so it's going to reflect the y values. This can be done by reflecting them in the x-axis, so basically up and down. So for the function we just had, if I was to do y is minus f of x, then the graph will be flipped in the x-axis up and down and will look something like so. If we have the minus sign inside the brackets, so like y is f of minus x, then it's going to affect the x values by reflecting in the y-axis this time. And so if I was to sketch the function, flip it in the y-axis, then it'll look something like so. So these are the 6 transformations that we need to be aware of. In A2, it does get a bit more difficult because we're going to be combining these transformations together. But for now, it's just going to be dealing with each one individually. So make sure that you understand what each one does separately and be comfortable with be able to sketch any different types of transformations.